Hey guys, the next set of videos I might have to make a couple for. I want to talk about limits analytically. I did a video on numerically, graphically, and then this is the last way we want to know limits. But this is kind of a big category, to be honest, so we have to talk about all the different types of things you could run into, and there's actually a lot of situations out there. So when I say analytically, what I mean is solving it with paper and pencil like we got in front of us, just real traditional. And let me give you an example here. I want to be able to give you a limit, and you don't have to graph it, you don't have to make a table, you can just solve it by hand. Sometimes they're really easy. Like for instance, the limit as x approaches, let's say 8. And I give you some function like 3x minus 1. I don't need to make a table, I don't need to make a graph. I can easily figure out this limit by pretty much literally just, sorry, that's my cell phone, and my battery's dying. I can figure this out by pretty much just plugging in 8 right away. So I'm going to do 3 times 8 minus 1. Some simple math is 24 minus 1, which is 23. Means if I was to make a graph and make a table, I would get the same answer. I'd get 23 as my limit. So a lot of times, you just plug the limit in and get an answer. We call it the plug and chug method. You can call it that, or you can just say you're substituting in a value. That's a little more mathematical, but I'm going to write plug and chug because you'll hear me say that. You should always try this first. Dang, my phone. I gotta turn it off. It's dying totally. So plug and chug whenever possible. It's the best strategy for sure. But a lot of times you're going to run into problems. So let me show you some problems. Here's an example. Example 2. I give you a limit. How about the limit as x approaches, how about x approaches 2? And this limit's for a fraction. And on the bottom of the fraction, I give you x minus 2. On the top, I give you something like x squared minus 4. I don't know, something like that. Your first step is always plug and chug, but look what happens when you plug in 2. You get 2 squared minus 4 over 2 minus 2. Doesn't matter what's on top of this fraction, there's a 0 in the denominator, which cannot happen. It's undefined. So most people want to try and say, oh, the answer is D and E, which would be nice and convenient and easy, but it's usually not true. Just because you can't plug it in doesn't mean there's not an answer for this limit. So avoid this. There's not going to be a lot of D and E ones. You're going to be able to solve this. You just need a backup plan. So we're going to talk about backup plans. This is backup plan number 1. Which of course, if you were to open up a math textbook, you're not going to see backup plan number 1 in your textbook. But this is a strategy. If I wanted to solve this limit, I could have done it like this. It's a factoring problem. I could have took the limit as x approaches 2, and I could have took the fraction and factored the top into 2 parentheses, so it'd be 2 parentheses with x minus 2 and an x plus 2 inside of it. It's technically the same thing as this thing up here, x squared minus 4. This is the exact same thing. And there was an x minus 2 in the bottom, but the factoring has helped me because I can cancel. And now I don't have fraction anymore. I now have the limit as x approaches 2, and with no fraction, it's just x plus 2. I no longer have an issue. I can plug and chug at this point. I've kind of eliminated the problem that I had earlier. So put 2 in there and do 2 plus 2, and my limit equals 4. And that's my answer. Definitely not D and E. So backup plan number 1 is try factoring. It'll work a lot. So factoring is one of our great backup plans. Here's another situation where you need a backup plan. New example down here. What are we on? Example 3? Example 3. Let's say instead of having to factor, you have kind of an opposite situation. So let's say you have something like this. The limit 0. Something simple. And you get this fraction, and it's already got parentheses, already got some factoring done to it, and it has something like x minus 3 quantity squared, and then some sort of minus 9 over x or something like that. You can't plug and chug. If you put 0 in, automatically you have 0 in the bottom of the fraction. You're also not going to use backup plan number 1 where you factor because it's kind of already factored. It wouldn't make any sense. So we have backup plan number 2. Backup plan number 2. And backup plan number 2 is the opposite of factoring. It's distributing. Why don't we multiply all of this out? We can use the FOIL technique. It'd be easy to do. So I'm going to write limit as x goes to 0. X minus 3 quantity squared means x minus 3 times x minus 3. And then we have this minus 9 kind of hanging off the back end, all over x. So I'm going to do the good old-fashioned FOIL method, multiply all these things out, and I'm going to get the limit as x goes to 0. I'm going to have x times x is x squared, minus 3x, so minus 6x, plus negative times negative is positive, 3 times 3 is 9. So there's my FOILed out answer, and I have a minus 9 off the back end, all over x. And it turns out nice because I have a plus 9 and a minus 9 that cancel. That's good. So in the next step, what I'm going to do is I'm going to write the limit as x goes to 0. Now I have these canceled, so I have x squared minus 6x all over x. I still have a fraction. I can't plug and chug yet, but every single item has an x now. So I can factor that out and cancel that out really easily, which means, clean that up, limit as x goes to 0. No more fraction, I have x minus 6. That's it. So plug in 0, I get 0 minus 6 equals negative 6. There's my answer. So backup plan number 2, we FOILed it out. It was the total opposite of factoring, and that means we distributed. So distribute, which works really well. Then we have one more backup plan. Backup plan number 3. So another example. This will be example 4. And for this one, here's a good example. Let's say you have the limit as x approaches 0 again. And this time I give you 5 minus square root 25 plus x all over x. I threw a square root in there. You're not going to factor this one, and you're not going to distribute this one, and you're not going to plug and chug because 0 goes in the denominator and you'd have issues. So we have another strategy. This is backup plan number 3. Backup plan number 3. The strategy on this one is we're going to multiply this thing by 1. And we have a fancy name for multiplying by 1. We call it the conjugate. You should remember this from last year. Conjugate just means I'm going to times the entire fraction by 1. Timesing by 1 never changes anything, but I'm going to not just multiply it by a normal number, 1. I'm going to make it a little fancier than that. I'm going to times this thing by the limit, let's rewrite this, as x goes to 0, 5 plus square root 25 plus x all over x. I'm going to times this by another fraction. Now we know with fractions that if you have like 5 over 5, it equals 1. Or 7 over 7, it equals 1. Fractions that have numerators and denominators, tops and bottoms that are the same, equal 1. So I'm going to multiply by 1, but this fraction is going to be a little weird. It's going to be the opposite of this thing. Oh, and I made a typo here. This should be a minus 1. So I'm going to multiply by, instead of 5 minus square root, 5 plus square root, 25 plus x. And the same thing on the bottom, 5 plus square root, 25 plus x. We call this thing the conjugate. It's the opposite of what was here. It's a plus sign instead of a minus sign. The whole fraction equals 1. But watch what happens. So I'm going to multiply all this out. Limit as x goes to 0. And I'm going to times the 5 by 5 and get 25. Minus square root times the square root. Those are going to cancel. So it's just going to be 25 plus x. On bottom, I'm not going to multiply all this out. It's just going to get messy. So I'm just going to write x times, big parenthesis, and then kind of copy all this junk. 5 plus the square root of 25 plus x. No reason to really multiply it out yet. Then I'm going to start canceling. 25 minus 25, that is very convenient for me. So that cleans it up. So what's going to be left on the top of this fraction? Look really carefully. There's a minus x left on top. Negative x is left on top. Over all this stuff that I didn't do anything with. X times parenthesis 5 plus square root 25 plus x. Okay, so look what cancels now. The x's. We're getting rid of things. This is a good sign. So we have the limit as x goes to 0. We have negative 1 left on top. That's it. On bottom, all we have is this thing. 5 plus the square root of 25 plus x. Now, ideally, we'd like to just get rid of the fraction because that's where the issue was. But I don't know if I'm going to be able to. I can plug and chug, though. Plugging in 0 is not going to give me any errors. Watch this. Negative 1 over 5 plus the square root of 25 plus 0. Not really an issue. The square root of 25 is 5. So I'm going to have negative 1 over 5 plus 5. 5 plus 5 is 10. It's not a big deal. So negative 1, 10 must be my answer. So this is kind of a different strategy. It's not really getting rid of the fraction, but it's making it better. So you can actually plug in the value. And we call this thing backup plan number 3 is the conjugate strategy. So to summarize, plug and chug any limit if you can. If you can't plug and chug, then go to the 3 backups. Either it's going to be factoring, foiling it out with the distributive property, or using the conjugate. There's other backup plans out there. These are not the only 3. But these are the big ones for our class. We still need to talk about trig and infinity problems, so those will be in the next videos. But you really want to have this down, this concept of the factoring, distributing, and the conjugating. So hopefully that helps. Watch for the next videos.